Hello everybody. In this tutorial we will see how to make branching system with tissue in Blender 2.80. This is still a development version, but most of the features are already here. Maybe in future some small things can change, but how it works should be almost the same. In this case, in order to create a branching system as usually for the tessellation, we need a base object and a component object. Our base object can be anything. We can use also this default cube that we can move like here. And we need to create now the branch. The branch is a bit more complicated because I have to take care of a couple of things. So let's create another cube that we can change and make it be our branch. So okay, let's start with the very basic shape of this branch. So we can go to edit mode, select this face, scale a little bit, moving upward, rotate a little bit, extrude a little bit, rotate, extrude. This will be one branch, and I want to create a second one like this. So we have this single branch that is splitting into two other branches. Now if we just do a tessellation of that object on that cube, tessellate, okay, we see that. Okay, and we have a couple of problems here. First, this thing is really distorted, so we need to change some settings because as you probably know, the normals of a geometry are moving in the direction of the vertices, and they are going in diagonal direction. And this is applying each component to the distorted shape that goes out to those vertices. And in this case, as for the extrusion, we have an option that is individual faces, that will consider just the normal direction of the individual faces without connecting those, interpolating those normals between the different faces. More practically, we can go to the data, object data, and here now, this is our news of this latest version of tissue, we have tissue tessellate settings here that we can interactively change, are the same settings of the tessellation that we have seen before. And in particular, we are interested in individual faces. And now you can see that the branches are going outward accordingly to the faces normals instead of the diagonal normals. Okay, another problem is that this branch here is not covering the whole area of our faces of our cube. And the reason is that by default is using component coordinate bounds. This means that it's checking automatically how big is the branch from the top view, and it's fitting perfectly with the face area of our base object. But in this case we have these two branches that are faking, they are altering how it is mapped, how it is applied to the faces. We want to consider just this area for start to generate our branch, and we want the freedom to make all the branches just spreading around without any constraint. So in this case, instead of using bounds, that is simple, but in this case it can give this kind of issue, we need to use local or global. I think that usually it's more easy to understand global, so we can just use global. And we need to, let's move that object here. We need to place this branch, making sure that the base of our branch is covering the part of the space that correspond with the first quad of the grid. So it goes from the origin to the point 110. And we can just change the location. By default, the cube is by default. The origin of the cube is in the center, so we can set the position to 0.5, and we can scale down as 0.5 our branch. So in this case, we are sure that this face is matching the quad of the grid. So if we check the coordinate of the different vertices, make sure to check the global because we are using the global coordinates, you should see that they are 1, 1, 0, 1, 0, 0, 0, 0, 0, and 0, 1, 0. Okay. Now, if we refresh this tessellation, okay, now you can see that all the different branches are starting from the faces of the cube. If we distort that cube a little bit, like this, and we refresh it, you see that it still matches. Okay. Another thing that usually we want to do is to merge the different branches. But you will see that if you choose merge and you try to add a subdivision surface to that object, they're not really merged, because merge works only with openings. So if you keep the base of the branch open, then you are able to merge all of them together. So if I delete that face here in the bottom, and I refresh it, I can still refresh from here. Okay, now you see that they are correctly merged together. If you want to see it smooth, you can activate smooth shading or no. Okay, let's remove the subdivision surface. Okay. Now, the other function that we need is the iterate. In object data here, we have some advanced settings that are by default hidden, but are available here if you press advanced settings. And what we need to use now are material ID, because we want that the next generation of branches will start growing only from certain faces. In this case, I want to use those extremities, this and this. And in order to do that, we need to make sure that we use different material for the different faces in order to be able to use the material ID. But before seeing that, the other thing that we need to use is reiterate tessellation. That allows to use the repeat function that automatically do another tessellation using this generated geometry as new base object and applying the branch again on that geometry, and again, iteration after iteration. Let me show in another example in order to keep things simpler. I have this cube here and I have just a plane. Okay, in this plane I'm moving this edge a little bit upward. Okay, and I'm doing a tessellation of that on that. Tessellate, I want to use fun in this case, and merge, and okay. And oh, wrong direction, so let's rotate again. Oh, okay, I actually want to make it going upwards, outward. Okay, like this. Well, now if I go to the tessellation settings and I try to use repeat, each time that I use repeat, it will use the generated geometry as new base object for repeating the tessellation. And in that way you can create recursive geometries and fractal-like patterns. And if we check it in edit mode, the previous iteration are not existing. It just keeps the last iteration. So in this case, if you want to create something like that, you don't have the overlapping of all the different iterations. In this case, in order to do that repetition, we don't want to use all the faces. Otherwise, we will get something like this. And it's not the branching system that we want. So we need to use repeat, but we want to make sure that we are repeating only on certain faces. In order to specify that we want to use some faces and not others, we can use materials. And remember that we are doing a tessellation on an object that in this case have only one material. So it's better to consider the material with index 0 as the material that makes things growing. So in this case we need a new material. It's not important that it's the same of the base object, and a second material. In order to make it more clear, I can call it grow, and the second one, don't grow, in order to make it more clear. So we can change the color of grow to pink and display the color from here. And now, as you can see, it's growing everywhere. So if I refresh it and I use material ID, that by default is index 0, you see that doesn't change anything. Basically, it's using all the faces for make the tessellation growing. So we need to exclude some faces now. We must select don't grow, select all the faces that we don't want. It's easier to select those, and Ctrl I for invert the selection. And now we can assign don't grow. We can change a little bit the color in order to make it more clear. Okay, now if I refresh it, you see that each time that you change the repeat value, you are seeing only the last iteration, like we did here. We didn't see the previous iteration, only the last one. But in this case, because it's a growing process, we need to see all the different iterations combined together. So here you can see combine iteration, and by default is just last. But you can use unused. This we combine each iteration with all the faces of the previous iteration that haven't been used. And in this case, it will combine these with all those green faces that are not being used in the previous iteration. So if you activate unused, okay, now you see all the branchings growing correctly. You can increase the number of repeat. By default, I added a stop to 5, but you can of course increase it manually. And something that you have to take in mind is that the size, by default, the size of each component in the Z direction depends, it's proportional to the face area. So it means that if you want to make some side of your branch growing bigger and some other smaller, you have to change the size of the faces. So you can, for example, increase a little bit this face here, and if you refresh, some parts are growing a little bit bigger. Let's increase a little bit more, and let's reduce that a little bit. If I refresh, now you see that it's more not symmetrical. Also, the rotation of each branch depends on the rotation of individual faces. You can select one face and use rotate face, and now if you refresh, you see that it's twisting differently, and again, so you can play around with that. Rotate, refresh, sorry. Okay, and you can of course change the shape of your branch. You can make it longer, this shorter, and you can see how it affects the growing of this object. You can also randomize the rotation. Now you see the more regular pattern because the rotation is following always the same rule, but you can use rotation random. And using this random seed, you can generate different possibilities. This is the most simple way to make branches in tissue using tessellate. Another option that I'm not showing here is to use the multi-components. Multi-components basically will allow you to use different branches and make each branch grow on different materials just according the name. Okay, I know, I say that I wasn't showing here, but I will do just for demonstrate how it works. So I can create a new component, and I can change this component a little bit. Maybe let me hide the previous one. Okay, so this is the first component, and we can call it comp A, and we can hide it. This second component, we can call it comp B. We can give it a different shape. So maybe we can, for example, decide that for this component, this face here is a dead end. So we need to use the material don't grow, assign. And in this case, we need to change the material name according to the name of the object that we want to apply to that material. So instead of using grow, in this case, let me make this material independent. I want to call it comp B. That is the name of this, the comp A, that is the name of the other component. And on the other component, we want to use the comp A here, but also add new material that we want to call comp B. Just make it different in order to make it more visible. Assign. Okay. So this branch have two different materials, comp A, comp B. Don't grow actually now is not really necessary. It's just necessary because we need a different material. Okay. And here we have a dead end, and here we have comp A. So if we select this and we uncheck material ID, reduce the iteration before doing any change like that. If we uncheck material ID, we can't use multi-component yet, because in our base object we don't have the correct material. So if you assign comp A to the base, here you can see that you can use multi-components now. Otherwise it will not generate anything, because the name of the material before was just material and there are no material objects listed here. So now that you have a material that have a corresponding object somewhere, now you can activate the multi-component. And now if you increase the number of iterations, at some point some of them will have a different branch. And you can see that you have at some point some dead end in your growth. We can make it more clear, maybe making, for instance, this component more different, even more different, like this. And you can see that at some point you have something different. And this depends on the rules that you are defining, just changing the repetition, the material name for each phase. Also, it's important that you try to keep all the faces as regular as possible, because very distorted faces can generate distorted branches. So try to keep them square if you can. Also this probably is not square. You can play with the scale of the branches if you want to make them longer or shorter. And that's it. I hope that you have fun using the branching system in tissue, and please, as usual, report any bug, any suggestions, any feedback. Thank you for watching.